Hello everyone and welcome back to another video, and today we will be working January 2021 math paper 2 question 3. If you haven't seen question 1 or question 2 before, you can check the description below for those links, or you can just check out the YouTube channel for the remaining videos. So here goes. So question 3 says the diagram below shows two pentagons P and Q drawn on a grid made up of squares. And they've shown us the two pentagons, and it says select the word from the following list to complete the statement below. So we have opposite, reflected, congruent, and translated. And then the statement goes pentagon P is dashed to pentagon Q. So we're filling in that dash with one of those words. One, we can look at it and we know that it is definitely not opposite. So pentagon P is not opposite to pentagon Q, so therefore we know that is definitely not our answer. We definitely know that it is not reflected, as a reflection speaks to a mirror image. It's like looking in a mirror and you're seeing the exact opposite of what is on the other side. Pentagon P is definitely not opposite to, is not the same, being reflected through a mirror line to pentagon Q. And what we know is that pentagon P is congruent to pentagon Q. We're going to explain the answer to part 2 for this. However, for those who are wondering why it's not translation or it's translated, we know that translation occurs when a figure is moved from one location to the next without changing its size. Well, that criteria was met. Without changing its shape, that criteria is met, but it doesn't change its orientation. And in this case, the orientation of P to Q was changed. So therefore, the only remaining possible solution is that pentagon P is congruent to pentagon Q. Part 2 now asks us to give the reason for answer in A1, which is that pentagon P is congruent to pentagon Q. So for those who don't know what congruency is, because both pentagon P and Q have the same exact shape and the size, then we say it is congruent. Also, they have the same area, which is 8.5 units, which is the squares that they both occupy. And that is what congruency speaks to. Congruency speaks to polygons or shapes having the same exact shape and the sides of polygons having the same exact shape and the size. So it doesn't matter where they were located, if one was on the left and the other was on the right. But once we can identify that they have the same shape and the size, so basically they have the same area, then that is considered to be congruent. So it's if one shape can become another using turns, flips, and or slides, then the shapes are considered to be congruent, and that is how we justify our answer to part 1. Part B now says the diagram below, not drawn to scale, shows the pentagon W, V, W, X, Y, and Z. In the pentagon, YZ is parallel to XW and YX is parallel to VW. And it says angle XYZ is 114 degrees and angle BZY is 98 degrees, and it says determine the value of angle WXY. So angle WXY. So we're trying to find what is the degrees right here at angle X, the magnitude of angle X basically. So therefore, to look at that, what we're going to look at is the parallel lines of YZ and XW that is being cut by this transversal YX. So therefore, what we know is that co-interior angles adds up to 180 degrees. So if we're looking at, when we're looking at these by themselves, we know it usually looks like this, and cut parallel lines cut by a transversal, and we know that co-interior angles adds up to 180 degrees, so they're basically supplementary. So that is the premises of what we're looking at these parallel lines here, and this is the transversal that cuts them. So therefore, these two adds up to 180 degrees. So 180 degrees. So angle ZYX and WXY will add up to 180 degrees. So therefore, ZYX is just 114 degrees plus angle WXY, which is what we're trying to find, is equal to 180. So we go ahead and solve for angle WXY. So we now have 180 degrees minus 114 degrees. And when we do that calculation, we'll get WXY to be 66 degrees. So that is our answer for part 1. So we considered YZ and XW to be parallel lines that is cut by a transversal, which is the line from YX. And then we considered the interior, so we consider co-interior angles to add up to 180 degrees. And therefore, since we know what angle ZYX was, we then subtract that from 180 degrees and we get the missing angle, which turns out to be 66 degrees. Part 2 now asks us to find angle ZVW. So angle ZVW. So we're now looking for what is the missing angle, the magnitude here at V. So this one requires a bit more thinking, but you're going to start with the same premises that we're looking at in part 1. So now we're considering the parallel lines of XW and YX, sorry. So YX and VW. And this is now being cut by this transversal WX. So parallel lines YX and VW, which is now cut by this transversal line. So what we know is that we just calculated the magnitude here at X, which was 66 degrees. So with this now being 66 degrees, what we know is that XWV and WXY, which we just calculated, our YXW, is equal to 180 degrees, as we're now considering these two angles here to be co-interior angles. So remember, the parallel lines are VW and YX being cut by this transversal, which means that these two angles here adds up to 180 degrees as they are considered to be co-interior. So therefore, angle WXV and VXY is equal to 180 degrees. We know what angle WXY is, which is 66 degrees. So therefore, angle XWV would then be 180 degrees minus 66 degrees, and we'll get angle XWV to be 114 degrees. So basically, the magnitude at W, as W is in the center of the order, it would be the magnitude at W being 114 degrees. Now we have 4 of the 5 angles that should be in this pentagon. What we know is that we can now, since there's only one missing angle, we can now find what is the sum of the total interior angles, then subtract the known angles from this sum, and whatever that remains would give us the magnitude at V, which is what we're interested in, the magnitude at V. So angle ZVW, basically the magnitude at V. So therefore, to calculate the interior angles, the formula that we're using is 180 degrees multiplied by n minus 2, where n represents the number of sides. So remember, pentagon 5 sides. So therefore, it will be interior angles is equal to 180 degrees multiplied by 5 minus 2, as there are 5 sides in a pentagon. So when we do that, what we'll have is 180 degrees multiplied by 3, When we put that in our calculator, we'll get the sum of the interior angles of this pentagon to be 540 degrees. So now that we know the sum of the interior angle, which is 540 degrees, we can subtract the 4 known angles from this pentagon from 540 degrees, and whatever that remains would be the magnitude here at V. So therefore, the known angles would be the 98 degrees plus 114 degrees plus 66 degrees plus 114 degrees, and that will give us the known angles to be 392 degrees in total. So therefore, now to get what the magnitude at V is, it would be 540 degrees minus 392, and that would give us 148 degrees. So therefore, angle ZVW, which the question asks us to find, is 148 degrees. We can check if this is true by now adding 148 degrees to 392, and we will indeed get 540, which is the sum of the interior angles in a pentagon. Part C now says the letter A and a point C.x.c are shown on the grid below. And it says on the diagram, accurately draw each of the following transformations. And part 1 says the enlargement of A by scale factor 2 about center 6.6. So I'm going to work this 2 ways. First, by using where we draw lines from the center passing through the object, so we can get the corresponding image. So what we're going to do is to draw points from the center, which is 6.6, through each point on the letter A. So we're drawing through this top one, this point here, and this point here. And now what we're going to do is to look at the distance of each point from the center. So we're looking at it from the point of a cross and down. So for this point right here, it is 3 across, so it is 1, 2, 3, and because we're going to the left, it's a -3, and 4 down, which is 1, 2, 3, 4. So we're looking at, so it is from here. So it is 1, 2, 3, and then 4 down, which is 1, 2, 3, 4. And that is what we're going to multiply by 2. So what we do is 2 multiply by -3 to give us -6, and 2 multiply by -4 to give us -8. And what this gives us is the position of where now this new point will be when it undergoes an enlargement by scale factor 2. So this gives us the position and not the coordinates on the graph. And we're taking a similar approach with this second point here. So what we're checking from the center, it is -1, so 1 across, and 1, 2, 3, and 1, 2, 3, 4 down. So -4, and it is this -1 and -4 that we're going to multiply by 2, which is the scale factor. And what we'll get is 2 multiplied by -1 to give us -2, and the 2 multiplied by -4 to give us -8. And this gives us the position of the second point, not the coordinate, so bear that in mind. And now we're going to the third point, which is the apex right here. So it is 1, 2 from the center across, and 1, 2 down. So it is a -2, -2. So what we'll get is -4 when we multiply that by the scale factor of 2, and this gives us the position of the third point. So now we can go ahead and plot our points. So for the first point, which is -6, -8, so it will be 6 across and 6 down. So it is 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8. So this right here will be the position where our first point is located, which is 0, negative 2. And as you can realize that both points are on the same line which extends from the center. So that is the aim of drawing these guidelines. It helps ensure that whatever point that you're plotting is on the same line, and therefore that is how you know that your answer is correct. So for the second point, which is negative 2, 8, it will be 2 across, so 1, 2, and 8 down, which is 1, 2, 3, 4, 5, 6, 7, 8. So this is where our second point will be, which now reads as 4, negative 2 in terms of coordinates. And for the third point, it is 4 across, 4 down, so it is 1, 2, 3, 4, and then 4 down, 1, 2, 3, 4. So this is where our third point will be, which is 2, 2 in terms of coordinates. And now we can join our points to give us our perfectly drawn A, which was enlarged by a scale factor of 2 about the center 6, 6. So remember, when you're using this method, when you're basically calculating the position of each point from the center, when you get the values of, for example, the negative 6 and the negative 8, that is not giving you the coordinates of the point, but instead it is giving you the position. So you need to do the same thing. So how far these points are positioned from the center, which was given on your graph. So then working it another way, what we're going to do, we can start by so this right here tells us how we can do it. So there are two ways, but the way I'm going to do it is by, so we can multiply by 2. So multiply by 2, then subtract the center. So we're going to multiply each point on our object by 2 and then subtract the center from whatever we get. Or we can do it by first subtracting the center from each point, enlarge by 2, and then add back the center. So what this does, unlike the first method, this gives you the coordinate of each point. So let's go. So first, if we're looking at this point of 3, 2, so 3 from the x, 2 from the y, we're multiplying it by our scale factor of 2. What we'll get is 6, 4. So remember, it would be row times column. 2 times 3, 6, 0 times 2 is 0. So what we'll get is 6 plus 0, which will leave us with 6. And you're doing a similar concept. 0 times 3 is 0, 2 times 2 is 4. So our points remaining is 6 and 4. We're doing now subtracting the center from this coordinate, which is 6, 6. So what we have is 6 minus 6 to give us 0, and 4 minus 6 to give us negative 2. And that will be where our first point is 0 from the x and negative 2 from the y, which is right there. For the second one, which is multiplying again our points 5, 2, so 5, 2 by the scale factor of 2, what we'll get is 10, 4. It is this 10, 4 now that we're now going to subtract the center from. So 10, 4, when we do 6, 6 from that, what we'll get is 10 minus 6 to give us 4, and 4 minus 6 to give us a negative 2. And then for the other point, which is 4, 4, which is the apex, 4, 4, we multiply by 2 and we get 8, 8, and we subtract the center from that, and what we'll have is 2, 2. So now looking at it, so for the 0, negative 2, 0, negative 2, these now give us the coordinates, unlike the first method that we were looking at. And then 4, negative 2, so 4, negative 2, and then 2, 2 for our apex. So 2 from the x, 2 from the y. We can now join and we get our perfectly drawn A, which is the same as that which was worked in the previous method. So now part 2 says, on the diagram we're drawing the transformation, the translation of A using the vector t, which is -3, 2. So we're just going to use this little formula of object plus translation is equal to image. So for the first point right here, which is 3, 2, we're going to add our translation of -3, 2, and 3 plus -3 will give us 0, and the 2 plus 2 will give us 4. And that will be the point of our first image. Then we have 5 and the 2 being added to the translation of -3, 2. So 5 plus -3 will give us a +2, and a 2 plus 2 will give us 4. And that will be the coordinate of our second point there. And the other point, which is 4, 4, which is the apex, plus our translation of -3, 2. It is 4 plus -3 to give us 1, and 4 plus 2 to give us 6. So what we have is 1 and 6. And that will be the point of our the coordinates of our third point. So I have 0, 4, so 0 from our x, 4 from our y, then 2, 4, 2 from our x, 4 from our y, and 1, 6, 1 from our x-axis, and 6 from our y-axis to give us the translation of A using this vector of -3, 2. It could have also been where we're using the translation vector to determine the new point. So this is -3, 2. So what it's saying is we're going across 3 times, so it is 1, 2, 3, and because it's a +2, we're going up 2, so 1, 2. For this point is the same thing, we're going to the left, which is -3 times, so it is 1, 2, 3, and then 2 up, 1, 2. And then for the apex, it is going across 3, so 1, 2, 3, and then up to 1, 2. So either method that you use, it will give you the translation of A using the vector t, which is -3, 2. And this is the end of question 3. Thank you for watching, and we'll see you for question 4.